Hi there. Today we're going to talk about lesson 59. And lesson 59 has to do with adding integers on the number line. As always, we have just a little bit of vocabulary. Let's define integers, because I think sometimes we get confused as to what an integer is. Integers include all whole numbers and their opposites. Because whole numbers always include 0, then 0 is an integer. But it does not have a positive or a negative that goes with it. It is neutral. Now, if we look at the integers on the number line, we'll notice that they start over here and they actually go in this direction forever, hence the arrow on the end of the line. And they go to the right forever, the arrow on the end of the line. Now, integers don't include decimals, and integers don't include fractions unless the fraction can reduce to a whole number type number. Because integers, remember, are the whole numbers. That's 0 through infinity, 1, 2, 3, 4, 5, 6, 7, 8, and their opposites, which is a -1, -2, -3. Now, one thing about integers is that we can talk about opposites. So, -6 here and 6 over here, those two numbers are opposites. They are opposites because they are the same distance from 0. So if I counted from here to 0 and I counted from here to 0, there would be the same number of spaces, 6 here and 6 here. Here's a list of integers in case you didn't remember how to write integers in a list. It is important, though, to realize that all numbers except for 0 on a number line are signed numbers, meaning they have a positive or a negative sign. 0 is the only one that doesn't have that. And by the way, that includes decimals too. It makes no difference whether they're decimals as far as sign is concerned. You can have a -0.765347 and 0.7564379, and one's a negative, one's a positive, but they're still numbers. They're just not integers. Okay? All right. Now, because of the fact that all numbers are signed except for 0, we have something that we call absolute value. Now, you've been exposed to absolute value before. Absolute value is pretty simple. Okay? It is just the distance from 0, the distance of the number from 0 with no sign attached to it. Absolute value takes away the sign because the distance has no direction. It is simply that, just distance. So, on this number line, you've got from 0 to 8 and from 0 to -8. No distance involved, or no sign involved, and so therefore it's just 8 units. Whether you go from -8 to 0, 0 to -8, 0 to 8, or 8 to 0, you're still only traveling 8 units. And that is the basis for absolute value. The distance is the same. So if we introduce the absolute value of -8 and the absolute value of 8, it is the same. It is 8 units, period. Now, these are absolute value signs, these little sticky looking things right here, okay? And they're straight up and down, and usually you will see some sort of a number in between the two of them. Here are some examples of some numbers that you could see in between them, okay? -4, the absolute value of -4 is 4, as well as the absolute value of 4 is 4. Absolute value simply means the distance away from 0. So I could take the absolute value of -1 and the absolute value, absolute value of -1/2 and the absolute value of 1/2, and I'm going to get the same answer because they are the same distance from 0. Same thing with this decimal down here. The absolute value of -2.98 is 2.98. Just as the absolute value of 2.98 is 2.98, because they are the same distance from 0. Okay, now you can find the absolute value of any number. They do not have to be an integer. I started with integers because I was wanting to introduce you to negative numbers a little bit. So let's do some absolute value math, shall we? Okay. The absolute value of 6 minus 9 equals -3 or 3. That's because we do what's inside. We kind of consider these parentheses. Okay, so there are in our PEMDAS arrangement, these guys right here are considered parentheses. So we want to do what's inside of them first. So 6 minus 9, which means you go to the right 6 and to the left 9, you're going to end up with a negative 3. Still inside these parentheses or absolute value signs. And then the absolute value of a negative 3 is just 3. Same way with this one below. You've got, 35 minus 4 equals the absolute value of 31. You solve this first, you get 31, you leave it inside the absolute value. The absolute value of 31 is 31. Now, that being said, note that the sum of two opposite numbers is always 0. So if I add 2 plus negative 2, I will get 0. If I add negative 1,000 plus 1,000, I will get 0. Okay, one more part to this. We can use the number lines to add positive and negative numbers and to problem solve. Now, some of you probably can already handle adding positive and negative numbers, and if you can, hallelujah, I am happy for you. But some of us still need to use the number lines just to help us to remember what direction we're going and what sign our answer should have. So, if I want to add a negative 4 plus a positive 6, I'm going to start at the 0 right here. And I'm going to move 4 to the left on my number line, which is negative. It's in a negative direction. I start at 0 and I move 4 to the left. Then, once I've gotten there, I will go up and move to the right 6 because the 6 is positive. When I get done, I'm to the right of 0 2 places, and so my answer is positive 2. Everybody see that? Kind of a cool way to do it. And for some things, especially when you're doing problem solving, sometimes it's not a bad idea to do that. Okay, here's another one with a little bigger numbers. You have 8 minus 12, or positive 8 plus a negative 12. Okay, so we start at 0, and it says positive 8, so we go to the 8 to the right, and we stop there, and it says go 12 to the left. So I go up, and then I move 8 to here, and then 9, 10, 11, 12, and then I come down to see where I land, and I end up on a negative 4, okay, which is right. If we rewrite this a little bit, we could see the directions say start at 0 and go to the right 8 units, then go to the left 12 units. It can be written this way, 8 minus 12, or 8 plus a negative 12. No matter how you write it, you are still going to get negative 4 as an answer. Okay, now, this is the last example I'm going to use, and this uses a vertical number line. And folks, sometimes for these kind of problems, this is the best thing you can do, is to draw yourself a picture. Okay? This is used well with altitudes, like above sea level, below sea level. It's also used well with temperature gauges, above 0, below 0, which we're familiar with at this time of year. Okay, so here is the problem. A group began their trip at 200 feet below sea level. So that's really a negative 200, right? Because sea level is 0. Then they ascended the mountain 645 feet. Ascended means to go in which direction? Yeah, ascended means to go up. Okay? So they ascended the mountain 645 feet. Where did they end up in reference to sea level? Okay? So we start here, we go down to where they started, which is at 200 feet below sea level. Then they go up 645 feet. Well, we know from here to here is 200. 300, 400, 500, 645 feet. Okay? So this ends up to be, I had that marked wrong, this ends up to be a positive 445 feet above sea level. And if we look at the problem with its signs and everything, this is a negative 200 here. a positive 645, and our answer is a positive 445 feet above sea level. Folks, it's never a bad idea, never a bad idea to draw a picture. Pictures are great. Well, I hope you have a great day, and I hope you enjoyed this. Thank you, and I'll talk to you later.